Yes, our cooperation with Africa started with the beginning of EUMETSAT. For the last 30 years, our satellites observe Africa on a continuous and very regular basis. The objective of our cooperation with Africa is to ensure that the users there have access to the data and also have the capacities to use them and exploit them.
So before talking about the activities, we need to explain why we are cooperating with Africa. And the reason is that our main geostationary satellite, EUMETSAT, is positioned over the Gulf of Guinea. So basically is observing much better Africa than Europe. And therefore for EUMETSAT as an organization, it is very important to make sure that our data are accessed and used by users in Africa.
They use EUMETCAST, and EUMETCAST is the main source of satellite data for the African Weather Services. EUMETCAST is based on standard satellite TV equipment. It's therefore affordable and accessible to many users.
There is a lot of advantage of using EUMETCAST data broadcasting. The accessibility is high volume, it is guaranteed, it's sure. The internet in Africa is not yet optimal.
So in order to receive the data from the EUMETCAST service, the users in Africa have been provided with receiving stations that is comprising of the outdoor units and the indoor units. The outdoor equipment is able to receive the signal from the satellite, and the indoor unit is able to process the data that is received from the satellite, and also to be able to display the data for the user.
Once we receive the data, we train the African user communities to make sure that they can efficiently use data in their various operational services. The main challenges we are facing as far as training is concerned is with regard to the expertise to teach people how to use some of the data and products. We ourselves don't have the necessary expertise for the use of some of these products, so we really need the data providers to organize training of trainer courses to give us the necessary expertise to be able to teach other people how to efficiently use these data and products.
We work with users across Africa through partnership. We work with 4 training centers, one in Pretoria, one in Niamey, one in Casablanca, and one in Nairobi. So we have a long history of working in partnership with these centers. What they bring is expertise in the meteorology and the connection with the weather services in those countries, and we bring our expertise of working with satellite data. And together we've had a good track record of working in partnership to help train African users.
The support of EUMETSAT in training African users has been very crucial through the organization of training the trainers courses and the organization of also face-to-face courses every year. And we have been also, with the assistance of EUMETSAT, carrying on online training courses using the facilities and expertise of EUMETSAT, of course, and all this for the benefit of the users' communities in Africa.
At the Security Division at EUMETSAT. So some background on this webinar. This event is part of a series of 3 webinars organized to keep stakeholders informed about the access
but what we're expecting
data
is climate.
Operated by EUMETSAT in support of sustainable.
Usually what we get is weather, but what we're expecting is climate. So is knowing how much weather has deviated from the long-term average. The key issue for climate monitoring within this region is the lack of data. Satellite data could fill in the gaps that the sparse observing network within the region brings in. But to realize the full potential of satellite data, what we need is a verification of the data and adapting algorithms that have been developed for other regions to our region.
In Africa,
the floor is yours.
Okay, can you hear me?
Yes.
Oui, André, on peut t'entendre. On t'entend très bien.
Yeah, good morning, everybody. I'm André Kamga from the African Center for Meteorological Applications for Development. I would like to welcome all of you for this webinar dedicated to sharing with the stakeholders, mainly the National Meteorological Services, the regional climate centers, the training centers and researchers, the existing potential in satellite data from EUMETSAT for Africa. So this second webinar is part of a series of 3 webinars, and it will be dedicated mainly to the climate monitoring over Africa from space. I would like to give the floor to Dr. from EUMETSAT, Dr. Paul Kunet from EUMETSAT, for his welcome remarks before we start the session. Thank you.
Merci, André. Merci and welcome to everybody. So I'm very pleased to open this webinar on behalf of EUMETSAT, and I'd like to welcome all the participants. So have you seen in part of the video that we have just displayed, having long-term records of data for doing climate monitoring is very important. And with METEOSAT, we are observing Africa since 1977. So if I count well, we have 44 years of data over Africa. And therefore, we believe that we have data sets which are highly relevant for climate applications in Africa. You've seen that the relationship between EUMETSAT and Africa is very important. And as we monitor the weather and the climate, it's part of our duty to make sure that we can use as much as we can all our data for the monitoring of the climate in Africa, and you know all the impact it might have. So this is the purpose of this webinar. We'll have a 2 days webinar with 2 sessions. Today we'll have more technical session. We will look a bit at the applications, but mainly we focus on data, how to access data, how to find data, and how to use the data that we make available to the African user community. And tomorrow we will have a session which is more a policy session. We'll look at the benefits. And during these 2 days, we are really also trying to establish a dialogue with you, even if it's not optimal through these remote technologies. We'll try to listen to you, to learn from you, and to assess how we can even better improve the services that we deliver to Africa and the projects that we develop together with you, our users in Africa. So with this, I would like to conclude my introductory words and wish you all very fruitful discussions in these 2 sessions of the webinar. Thank you.
Thank you, Paul, for these insightful introductory remarks. I would like to hand over to Mimi for some information around the Zoom functions, the Slido tool, and the live streaming on YouTube. Mimi, you have the floor.
So thank you very much. Good morning and welcome to this webinar. I'm going to give you an introduction into our Slido tool. This Slido tool is very important because you won't be able to be writing your questions and answers over Zoom. So I'm going to share my screen to show you how it's going to work. So this is Slido. Let me go back. So if you go to the website, Slido, So www.slide.do, you get you this landing page. And then if you put in our hashtag, so it's EO Africa. So that's it. And if you put it in, you can join as a participant. And then you can put in your name. So in my case, it is Mimi. And then you can join. And once you do this, you have access to the question and answer tool. So you can put in your live questions and answers here. And questions can also be upvoted if they're more interesting to most of them. So you can look at them here. And then there's also going to be a poll, which is going to be going throughout the day. So this poll is going to be a small quiz. And it's also called, do you know your satellites? So in between presentations, I'm going to be asking 5 questions. And you can be playing along over here. So I think that's it for now. So I give it back to André.
Thank you. Thank you, Mimi, for this information. So as indicated earlier, this day's session aims at informing current and potential users about data, tools, and training on space-based climate monitoring. And we will then now move to presentation on these 3 elements: the data, the tools, and the training that particularly EUMETSAT offers in Africa to effectively use the data and products. So I would like to introduce Mrs. Marie Dutroux-Boucher from EUMETSAT. And it's an introduction to EUMETSAT climate monitoring activities over Africa, which will show the importance and value of climate monitoring and what it can do actually for the African continent. Please, Marie, you have the floor.
Ok, merci beaucoup. Bonjour à tous. Donc, je vais vous présenter ce matin ce qui est fait à EUMETSAT au niveau des données climatiques. Est-ce que vous pouvez voir mon écran ou pas?
Oui,
voilà.
Oui,
c'est bon, d'accord. Je ne voyais pas le… Ok. Donc, 2 grandes catégories de données climatiques sont disponibles à EUMETSAT. Tout d'abord, les données d'observation à pleine résolution, qui sont en général des luminances, qui ont été retraitées et qui sont donc correctement géoréférencées à la fois en temps et en espace. Et elles ont été aussi réétalonnées. La deuxième grande catégorie de données disponibles, ce sont des relevés de données climatologiques ou des séries temporelles en fait, de variables physiques ou géophysiques, comme par exemple la température, la précipitation, l'albédo, le vent, la nébulosité ou des bilans radiatifs. Next slide. Donc, en fait, ces données pourraient être améliorées et homogénéisées afin de créer des données climatiques historiques, des données climatiques de grande qualité. Il va être nécessaire de les retraiter parce que les données en temps réel ne sont pas utilisables en tant que telles. Donc, pourquoi est-ce qu'on a besoin de retraiter ces données? Il y a plusieurs raisons à ça. Tout d'abord, parce qu'on va pouvoir utiliser, par exemple, de nouvelles données historiques qui n'avaient pas été utilisées à l'époque. On va pouvoir remplir des trous qui existaient dans les données originales. On va pouvoir également réétalonner des données a posteriori. Retraiter les données, ça va également nous permettre de retraiter l'ensemble de la série avec le meilleur algorithme scientifique qui est disponible en temps réel en ce moment sur l'ensemble de la série. Et pour retraiter ces données, on va aussi, si on les retraite maintenant, pouvoir utiliser des données auxiliaires utiles pour les restitutions, les données auxiliaires de meilleure qualité qui vont être utiles pour les restitutions des variables géophysiques. Next. Donc, pendant pratiquement 40 ans, enfin, ça fait 40 ans que des données satellites sont archivées à EUMETSAT et ça a été à partir des données acquises à partir des 11 satellites météosat de première et de seconde génération qui se sont succédés au-dessus de l'Afrique. Ces données ont été retraitées et on a donc produit des données climatiques fondamentales. Et je vous montre ici une série moyenne de températures de brillance dans le canal infrarouge au-dessus de l'Afrique. qui a été obtenu à partir de 8 des 11 imageurs à bord des satellites METEOSAT. Chaque couleur correspond, sur la courbe correspond à un imageur d'un satellite particulier. Vous voyez bien ici des oscillations de température qui correspondent aux alternances d'été, des périodes d'été et d'hiver. Et on constate que grâce au retraitement qui a été fait, cette série elle est très stable et très homogène au cours du temps. Il va donc être possible de générer des variables climatiques essentielles à partir de ces données climatiques fondamentales. Next. Et donc, on a des données fondamentales stables et ça va permettre de générer donc des données climatiques qui vont fournir des informations très fiables sur la manière dont les terres, l'océan, l'atmosphère, les calottes glaciaires vont évoluer sur des grandes périodes. Et on va aussi, grâce à ces données climatiques, comprendre à quel endroit et à quelle ampleur ces changements sont possibles. Donc, je vais vous montrer 2 exemples d'applications qu'on a réalisées avec des séries temporelles à partir des observations satellitaires géostationnaires. Next. Donc, la première application dont je vais vous parler, c'est l'albédo de surface. L'albédo de surface, c'est une des variables climatiques essentielles parce qu'il contrôle en grande partie la quantité d'énergie solaire qui est disponible pour le système Terre. Et l'albédo de surface, finalement, c'est une mesure de la brillance de la surface. Un sol très brillant va réfléchir la quasi-totalité du rayonnement solaire incident. Et par exemple, lorsqu'il y a un manque de précipitation, lorsqu'il y a beaucoup d'activités humaines, lorsqu'il y a eu surpâturage, déforestation, des incendies, il va y avoir un appauvrissement de la végétation sur la Terre, ce qui va se traduire par une surface brillante, et c'est ce qu'on va observer à partir des satellites. Donc, on a généré à EUMETSAT une série d'albédos climatiques au-dessus de la surface du continent africain. Et cette série temporelle va décrire l'évolution de cet albédo avec un échantillonnage de 10 jours pour une période qui s'étale de 1984 à 2017 ou 2018 au-dessus du continent africain et également au-dessus d'une partie du continent indien grâce aux satellites qui, depuis 2001, observent cette région du globe. Next. Donc, grâce à ces observations satellitaires géostationnaires en particulier, on va pouvoir, ça va montrer que ça a un rôle clé dans les études climatiques dans des régions où, par exemple, les mesures des satellites polaires vont s'avérer insuffisantes. Donc, par exemple, au-dessus du Sahel, qui est la région où il y a une transition entre le Sahara au nord et la savane au sud, c'est une région au Sahel où il y a eu des grandes sécheresses dans les années 70-80. Donc un albédo qui est censé qui va être plus brillant. Et on a fait des études pour voir si on est capable a posteriori, mettons, de voir ce qui s'est passé au niveau des années sèches et humides. Donc le mécanisme qui lie l'albédo de surface à la diminution de précipitation est connu depuis longtemps. C'est un effet local qui est couplé à un mécanisme complexe de rétroaction à grande échelle par des variations à grande échelle interhémisphérique de la température de surface de la mer qui va réguler la force de la mousson africaine et c'est essentiel en fait pour la précipitation sur le Sahel. Ce mécanisme a été mis en place par Charnay en 1977. Et on a couplé 3 variables climatiques essentielles, l'albédo de surface, la précipitation et l'indice de végétation. C'est ce que vous voyez sur la courbe en haut à gauche où vous avez une relation saisonnière entre ces 3 quantités. En fait, il y a un décalage d'1 mois entre la précipitation qu'on voit en bleu et la croissance de la végétation en vert et l'albédo de surface qui suit les changements de la couverture végétale. Et lorsqu'on prend 2 années très contrastées en termes de précipitation, comme l'année 2003 qui a été très humide sur le Sahel et l'année 84 très sèche, eh bien, on a fait une carte ici de différence entre les mois de août, septembre et octobre sur ces 2 années et on voit une diminution très nette de l'albédo de surface d'environ 8% sur une zone aux alentours de 16 degrés de latitude nord, sur une petite zone de 2 degrés de large. En fait. Si vous voulez en savoir plus sur ce cas d'étude, vous pouvez aller voir le site EUMETSAT, j'ai mis le lien sur les slides. Next. Un deuxième exemple d'utilisation des données satellites pour comprendre le climat et l'atmosphère, c'est les vents satellitaires. Donc, le principe pour déterminer des vents, c'est très simple. On a une image. Dans chaque image, dans une image, on va repérer une cible, c'est-à-dire en fait une petite zone très contrastée. Et comme on sait qu'il y a entre 2 images 15 minutes, on peut calculer en divisant la distance par le temps, le vecteur vent, auquel on assigne une vitesse, next, et on va ainsi pouvoir générer environ 10 000 vents par heure, next. On a donc une série climatique de vents unique, et ce vent, on voit cette série là sur la courbe que je vous montre ici, c'est 40 ans de données avec la vitesse du vent atmosphérique à différents niveaux, en bas de l'atmosphère, où il y a une vitesse d'environ 10 mètres par seconde, et en haut de l'atmosphère, comme il y a moins de friction, la vitesse est beaucoup plus forte, elle est à peu près de 25 mètres par seconde. Mais on voit que cette série est très stable, et ça va permettre de faire des tas d'études climatiques. On peut par exemple essayer de quantifier, on peut regarder avec ces données l'analyse de la mousson africaine si on les couple à des informations sur les océans telles que la température de surface des océans. Next. Donc, si vous voulez accéder aux données climatiques qui sont réalisées à EUMETSAT, que je vous ai vraiment très brièvement montré deux exemples, vous pouvez aller sur le site web de EUMETSAT. On a un service de données opérationnelles qui couvre 35 ans de données météorologiques en temps réel et historique. Ce service opère 24 heures sur 24, 7 jours sur 7, et ça permet d'avoir accès aux données, soit en mode push, comme les services EUMETSAT, soit en mode pull via l'archive et des services comme EUMETView. En ce moment, l'accès aux données à EUMETSAT est en train d'être restructuré. On a 5 nouveaux services indépendants, mais qui vont être intégrés dans une stratégie plus large de distribution de données qui est en train d'être mise en place. Donc, on remodèle en fait le portefeuille de services de données en tirant parti cette fois-ci du big data et des technologies de cloud computing, de manière à introduire des nouveaux services et de faciliter l'accès aux données en temps réel, la visualisation aux données, la transformation personnelle de données, le traitement d'images directement à côté des archives dans les nuages. Next. Donc, on a un point d'accès centralisé aux données, à la fois aux produits real-time, historique et Climate Data Record, qui est le Data Store. Ça, c'est un catalogue de données qui est dans sa phase pilote, mais qui va s'enrichir de plus en plus. Et avec ça, vous allez avoir des API qui permettent de traiter un petit peu les données directement sur place, permettre d'avoir un catalogue interactif pour rechercher des données auxquelles vous êtes intéressé. Next. Il y a le service EUMETView. EUMETView, c'est un service de visualisation en temps réel où l'utilisateur va pouvoir regarder les images, les produits de façon interactive. Next. Donc, en résumé, si vous voulez accéder à toutes les données satellitaires de EUMETSAT, vous pouvez le faire via donc, le portail d'observation de la Terre du site web de EUMETSAT, sur lequel vous avez un catalogue en ligne qu'on appelle le navigateur de produits, où on peut regarder les données. Donc, c'est le lien qui est en haut dans ma slide. C'est disons, le catalogue actuel. Et si vous cherchez des produits climatiques, j'ai mis le mot en rouge « release » parce que ça aide à trier les données en fait, dans le catalogue et à tomber sur les données climatiques. Et donc, il y a un nouveau service qui est en train de se mettre en place, qui est le Data Store. Je vous ai mis les deux liens ici, où vous pouvez accéder à certaines données, notamment les données climatiques fondamentales de Météosat se trouvent actuellement sur le Data Store et pas sur le produit, et pas sur le navigateur de produits. Si vous avez donc, il faut vous enregistrer en ligne à EUMETSAT et aller regarder un petit peu sur ces deux sites. Si vous avez des problèmes, vous pouvez toujours contacter notre service aux utilisateurs et j'ai mis le lien dans le transparent ici. Voilà, je vous remercie pour votre attention.
Merci Marie pour cette présentation. Thank you, Marie, for this interesting presentation. Highlighting data available from EUMETSAT and even tools for visualization, as well as the new archive under development. Yeah, I should probably mention something important across Africa, is that we are currently building warming rates over Africa. As you know, we all know about the global warming level and rates. But over different areas in Africa, it is still an ongoing effort. And this data store presented by Marie could be useful at the country level, even at the level of a given city, particularly mega cities. It could be useful to actually look at what the warming level and rates are to inform our negotiators at the UN climate conferences. We'll give the floor to Mimi for the quiz question. 1 minute, please, so that we go on quickly. Thank you, Mimi.
Thank you so much. So we're now going to the quiz. So please have your Slido open. And if you haven't put in your name now. I'm about to start with the first question. So we're going to have one question. After this question, there's going to be some presentations, and then I'm going to continue on until we have all 5, and then we have the results. So I'm starting the quiz. So I'm starting the quiz now. So let me share my screen to make it easier for you to follow. Good. Question 1. In what year was the first meteorological satellite launched? Okay. So the correct answer is 1960. So most of you had it correct. That's really good. So here's the leaderboard for everybody. And then we're going to continue with the next question after the next 2 presentations. Here you go, Andre.
Thank you, Mimi. Now, as you all know, food production is a result of a lot of processes going on our land. And satellite is one of the instruments that we use to analyze the land surface. So the next presentation by Isabelle Trigot will actually address the use of satellite data for land surface monitoring. Mrs. Isabelle, you have the floor.
Thank you. So hopefully you are now seeing my screen.
Yes.
Can you confirm? Yes. Well, thank you, Andre, for this very good introduction. I have to say it's really a pleasure for me to be here and to be able to provide you an overview of what we are doing at Landsat, EUMETSAT Satellite Application Facility on Land Surface Analysis. And I really hope that I will show a couple of examples for Africa, and at the end that you have interest to find out more about what we are doing and explore our data for your regions of interest and applications. So the Landsat is part of the EUMETSAT network of SAFs, a set of centers dedicated to explore more EUMETSAT observations and satellites. In the case of the Landsat, we are dedicated to derive products and information that allow us to describe the land surfaces and the processes that occur over land surfaces. And our products follow basically these 3 thematic areas that you are seeing there in your screen. So we have a range of data that is aimed at describing the full radiation budget at the surface, a set of data that target vegetation, and by that I mean that we want to understand and to follow the state of vegetation, to assess the vegetation stress, and also to look into and monitor wildfires. And because all of these themes, so radiation, vegetation, and energy balance are all interlinked, in the end, we also attempt to fully describe the energy balance, all the energy balance components at the land surfaces, and with that derive evapotranspiration, turbulent fluxes, and so on. So what I'm going to do next is to focus on some of these products more specifically to show you what we are doing. So one example, an important one, I think, of products that are related to surface radiation is land surface temperature. Land surface temperature that you get from satellite data is the radiative skin of the interface between the land and the atmosphere. This is not air temperature nor deeper soil temperature, but of course they are all these various near surface air temperature and land surface temperature. They are highly correlated, and you can and should use this LST from satellite data, for instance, to assess areas with cold spells or heat waves. This is perfectly fine. This data, this land surface temperature first and long data that we have is being derived since 2004. So we do have a record of LST that starts in 2004 and is continuously updated in near real time. These data are generated with a frequency of 15 minutes and have a spatial resolution of about 3 kilometers over nadir. Most of the Landsat products, I should say, are derived from Severi instrument, which is on board Meteosat second generation. And as you have already heard today, Meteosat satellites are optimally located to provide high-frequency observations over Africa specifically. I have a set of links there where you can learn more about these products, about land surface temperature in particular. So we do have a tutorial that you can follow and you can see examples on its use. Then I had already mentioned that we do have this range of vegetation products. I start by introducing to you the fraction of vegetation cover that accounts for the amount of green vegetation that is on each pixel. Again, we have this data from 2004 and it is being continuously updated. And we also have a set of modules and training modules that you can look into to find out more how to use this data. I would like to highlight that this product fraction of vegetation cover together with leaf area index that is also retrieved from Meteosat second generation and the fraction of absorbed photosynthetically active radiation, so FAPAR, together these FEC, LAI, FAPAR provide complementary information on the density of vegetation and on vegetation health. And these data, you can access them. So these are derived either on a daily basis, meaning that you can follow sharp changes in vegetation using these geostationary data, something that it is much harder to do if you use polar data, polar orbiting data that is observations with less frequency than what you get from geostationary satellites. Coming to water stress, we do provide also evapotranspiration, which accounts for the amount of water that is either evaporated from the Earth's surface or that is transpired by vegetation. And this data is available every 30 minutes or on a daily basis. And we are now in the process of back processing all of this from 2004 onwards to present, so that, again, you have a reasonably long data record for our analysis. Equally important and very easy to use, I would say, regarding water stress is reference evapotranspiration. This is a kind of potential maximum evapotranspiration that you get. So it's the evaporative demand from the atmosphere. And it corresponds to the evapotranspiration of a surface, a green surface, that would never be water stressed, like the green field that you can see there in the picture. And regarding fires, we are also doing fire radiative power. So FRP stands for fire radiative power from Severi. This data, again, I stress that Severi on board, Meteosat second generation, providing observations every 15 minutes, allow us to monitor a kind of event, these kind of events that have not only a strong seasonality, but also a very strong diurnal cycle. So this is an image, what you have there is an image from 1 week ago or so at 12 UTC. And if we would see each image every 15 minutes, you would see the maximum activity following the peak of the day along the satellite disk. And on a seasonal basis, an annual basis, you would also see this maximum activity of fire and fire intensity always following the dry season over Africa. And with this data, you can not only monitor fire activity, but in fact, the radiative power emitted by fires is very closely linked to fire emissions as well. So that's why we are so interested in maintaining this data. And again, these data are available every 15 minutes. If you go to our website, I have the link there, you can see near real-time images of FRP, fire radiative power. Well, it would not be possible for me to go through each of the products and variables that we are now deriving at Landsat. So there are a whole range of variables. We recently started to generate gross primary production, for instance, and we also have albedo, solar, including diffuse and direct radiation, long wave radiation, and even null sky land surface temperature that we have recently started also producing. And these are all available on a free and unrestricted basis. All data are thoroughly validated as well, including using available in situ data in Africa, and therefore they have a maturity that is considerably high and good to use for climate purposes. I just wanted to remind you, although we have all these variables and data from Meteosat second generation, we also do provide variables from polar orbiting satellites, so METOP mostly, so a set of land surface variables from METOP data that are available on a global basis and with higher spatial resolution, but not with this rich high-frequency sampling that we have from Meteosat second generation. And just a note on the format and distribution means of all this data. So all the Landsat data are available on two different formats, HDF5 and NetCDF. The NetCDF data are projected on a regular grid, while the HDF5 is closer to the original data, if I can say it like this. So on the case of the MSG data, they are on the original geostationary projection. We are also distributing this data via EUMETSAT. In the EUMETSAT channels, we only distribute the HDF5 data and the high frequency data, so those products which are generated every 15 minutes up to daily. But you can access in near real time as well through FTP all of the data, HDF5, NetCDF4, everything. Please contact us to the help desk, to our help desk, if you would like to access the data in near real time or offline, or if you have any questions, we will be more than happy to answer them. Now, I would like to show you just a few examples of applications of this data over Africa. So in the bottom, you have a map with anomalies of land surface temperature. As I said, you can and should use land surface temperature to check which areas are warmer than expected or cooler than expected. This is a figure for December 2019. And on the top, we have a time series of these LST anomalies for an area that is marked here in Southern Africa. And I have here the full data record from Meteosat second generation. And what is striking here is that towards the end of this data record, so starting in October 2018 onwards, you have this prolonged period with very warm temperatures over Southern Africa, which is actually associated to a drought, a severe drought that has also its signature on vegetation in the area. So below you have the same thing, so the time series of the fraction of vegetation cover, and in the lower panel, the anomalies of fraction of vegetation cover, where you can see periods where vegetation growth was above or below average. And you can clearly see the impacts of these droughts in the later years on vegetation and as well. So all these variables, and it is kind of true for most variables for overland surfaces, they are very much interlinked, and you can see signatures on temperature, vegetation, fire activity, etc. Just another point, another example. So what you have here is a map of reference evapotranspiration from Meteosat's second generation that I've zoomed over the Eastern Africa area. So if you remember, this reference evapotranspiration represents the atmospheric demand of water from plants, from the surface, and you can even compute crop water requirements from this reference evapotranspiration. The figure on the right shows the anomaly of reference evapotranspiration, so showing whether crops are being more stressed than usual with respect to water demand. And you can see, for instance, in northern Kenya here, that there's been, so this is from December 2020, so last December, I think I forgot to say, that there's been an increase in water demand for plants over this region. Let's take a look at a vegetation data set. In this case, it's AFAPAR. And we do see this brownish area already showing that vegetation is getting under stress and photosynthesis activity is below average. There are also another areas where you have greener vegetation, so more photosynthesis activity. And in fact, this signal has nothing to do with this evapotranspiration one. It's a long trend that you see, a long trend greening over many parts of Africa that are mostly related to agricultural practices, so changes in land use and agricultural practices in Africa. So these were just two types of applications that I would like to show and highlight how you can look into this data further for your area of interest and looking at how the atmosphere controls vegetation, temperature, and water demand. Just before finalizing, I would like to invite you to visit our website, which the link is showed there, and to browse through our catalog. So if you go here, you can choose the catalog. You can also look into the product gallery that will pop up in this list. And in the product gallery, you can see our data in near real time, so recent data, fire, vegetation, and so on. To download data, you should register into our webpage. That it's pretty straightforward. And of course, as I've already said, please do send us your feedback and questions to our help desk email, and we will be more than happy to help you and to provide all answers to your questions and queries. Well, thank you very much. I hope that this presentation, it was short, but has opened your appetite to learn more about the data and the activities that we do within the Landsat. Thank you.
Good. Thank you for the presentation. Just to recall that we are still in the climate system, because it has a set of components. One of them is the land surface, followed by the biosphere, the atmosphere, and the cryosphere. The next presentation would actually look at the satellite-based climate data record for climate monitoring and other applications by Dr. Trent Mann from DWD. Dr. Trent Mann, you have the floor.
Yes, thank you for this introduction, and thank you for inviting me to introduce the CMSAF here at this opportunity. So far, I'm still not seeing my slides. Okay, here they are. So yes, thank you. So I will briefly introduce the CMSAF and the data and services that we are providing on satellite-based climate data records. On the next slide, I just give a brief overview of what the satellite application facility on climate monitoring is actually doing. So we are developing, generating, archiving, and most importantly, of course, distributing satellite-based climate data records. We are focusing our products on the energy and water cycle, and I will provide in a second more information on what that is. So we do this to support monitoring, understanding, and in the end, of course, also adapting to climate variability and climate change. The next slide gives an overview of a handful of climate data records that we are providing. So as I said, we are providing a variety of climate data records from different geophysical parameters, including clouds, radiation, surface parameters like albedo, as well as precipitation. However, the latter we only provide over the ocean. We are providing global and regional data records from the 80s till very recent data like the day before yesterday. The temporal resolution depends on the satellite instrument and goes from like 30 minutes or maybe even 15 minutes, but all data records are provided as daily and monthly averages as well. On the spatial resolution also differs from the satellite instrument we are using and goes from 0.05 degree to 1 degree. The data is freely available on our webpage. This slide shows the 6 most relevant data records coming from the CLARA data record and the HOAP data set, both are globally available data records. And then we have the SARA and the CLASS data record, as well as the COMET and the SUMET data record. All data records will also be updated within the next year. And some of those data records, namely the CLARA and the SARA and the CLASS data record, also provide near real-time extensions, so-called ICDRs, interim climate data records. Next slide, please. This is how you can access the data. So we are providing a so-called web user interface that allows a selection and, of course, the online ordering of our data. We also have the option that you can select a regular data delivery, so-called a standing order. What I really like about this user interface, which I think is really useful, is that it allows a spatial subsetting. So you do not have to download the full spatial resolution, full spatial coverage, but you can zoom into the area that you are mainly interested in. Data format is a netCDF, and it will be provided on an HTTP or SFTP server. Of course, all data are free of charge. Another way to access the data on the next slide is the EUMETSAT. So some of our products, namely the daily and monthly sunshine duration and surface solar radiation, as well as the monthly fractional cloud cover, is also provided through the EUMETSAT channels listed here. Next slide, please. Besides the data, we also provide a tool to look at the data. And this tool is the CMSAF R toolbox. It's based on the open source software R that runs on all operating systems. It's designed to access, analyze, and visualize the CMSAF and also other SAF data records. It's based on, as I said, on the open source software R, so it can be used within scripts and can be used within really like programming software. But to start with the analyzing, no programming skills are required. So it has a graphical user interface. Also, we are providing many tutorials, also video tutorials that help to get started with using the CMSAF data. So essentially, the 3 steps you can take, which is prepare, analyze, and visualize the CMSAF data with this free and open source software. Next slide, please. So now I want to briefly highlight one particular data record that I think is very useful for a lot of applications, which is the SARA data record. SARA stands for Surface Solar Radiation Dataset HelioSat. It contains surface radiation parameters, namely the global radiation or the irradiance. This is the total solar radiation reaching the surface. We also providing the direct irradiance and the sunshine duration, which is like just the hours of sunshine based on the direct irradiance. The spatial resolution of this data record is very high. It's close to the original satellite resolution, 0.05 degrees. And we are providing this with a 30-minute as well as daily and monthly temporal resolution. This data is available from 1983, so we're using the first generation of EUMETSAT satellites, as well as the second, of course, to estimate these parameters. Next slide, please. So the data doesn't end in 2017, but we are providing a consistent near real-time extension. And when I say near real-time here, it's I mean with the day before yesterday. So it's you will get the data 2 days delayed. But this is also available from 1st of January 2018. It's called the so-called SARA ICDR. So this, of course, allows you to use the data records for more or less operational climate monitoring. So on the next slides, I'll briefly introduce a couple of applications that are already around, available, and might also stimulate further applications. So this is one application that we in the CMSAF prepared, which we called Sunny Days. So we use the solar radiation data to estimate for specific cities around the world the climatology of sunny days. So the question is, on which day of the year, what is the likelihood of this day being sunny? And sunny, we defined that the daily radiation exceeds 80% of the clear sky radiation. So here I picked two cities, Abidjan on the Ivory Coast, where you can see that the annual cycle is such that in January, February, there's a high likelihood of a sunny day, while in September, August, September, there's a low likelihood of a sunny day. And more or less the opposite is in Tanzania, in Dodoma, for example, where if you go there in September or October, you will very likely get a very sunny day in this time of year. So on the next slide.
You can, probably summarize.
And the next slide is the another application that's very popular, which is solar energy. So for the planning of solar energy installations, one requires climate data for at least 10 years to get an idea of how long it takes to harvest sufficient sun for the investment, basically. So here I've just briefly introduced two tools. One is the PVGIS tool from the Joint Research Center in ISPRA. They provide this tool, and among other things, they're providing maps of the photovoltaic energy potential for Africa in this case, but also for each individual country. I picked Ethiopia in this case. And then another example, this is from the Egyptian Ministry of Electricity and Renewable Energy. They prepared a solar radiation atlas for Egypt, for their particular country, obviously, also using the CMSAF SARA climate data record. And on the final slide, I just introduce climate monitoring possibilities of these data. So on the left side, you see the sunshine duration anomaly from last year. So overall, there was a slightly reddish color, which is more sunshine duration, a longer sunshine duration than our average, particularly over the Atlantic Ocean there on the African west coast. However, in East Africa, there was less sunshine duration than on average. Yeah, this of course you can also zoom into much more. On the right side, I picked another country, in this case Botswana, and looked at the accumulated sunshine duration for this year. So this is all the data ending like last week, 29th of May. So in 2021, so far we had 1,270 hours of sunshine duration, which is slightly less than the average sunshine duration, 1,310 over the last 30 years. And you can see on the right side also that it's mainly the northwestern part of the country that received less than average sunshine duration. These figures were all generated using the server data and the CMSAF toolbox without any programming attached to it. So these can be generated rather easily. So my final slide just summarizes what I just said. So the CMSAF provides free, documented regional and global climate data records starting in the 80s. All the data are regularly updated and extended. For some data, we're providing a timeliness of the data with about 2 days. I introduced the CMSAF toolbox, which we find it very useful for data exploration. The data has already been used for many applications, and we are ready to support additional new applications of our data. Have a look at our webpage, and if you have questions, just send us a message through the contact email address here. And with this, I thank you for your attention.
Thank you for this presentation, which actually showed a lot of products on the atmosphere component of the climate system. We would indicate that benefit from this specific product include the design of solar power programs, and we will probably discuss tomorrow how this can be used actually for that purpose. Let's move to the next presentation by Christine from EUMETSAT also on the data cube for drought and vegetation monitoring. Christine, you have the floor. Please be brief, given the fact that we are short of time.
Thanks very much, Andre. I try to do my best to stay brief. Can I have then the next slide, please? So as you have heard from my previous presenters, many of the EUMETSAT climate data records, and especially many of the EUMETSAT data records on geophysical variables, on climate variables, essential climate variables, are created within the network of our satellite application facilities. And the next slide, please. The current situation is that here you see a list of SAFs, not all the SAFs, but the list of SAFs that are most important in providing climate relevant data records to users. From a user's perspective, one of the challenges at the moment is to access these data. This is because each SAF has its own way of providing the data to its users, making them available. They're available in different formats on different grids, and sometimes they even have differences in the metadata. This is all the case for very good reasons, but when a user would like to work with data from different SAFs, this can be a barrier to use this data, and this is what we try to mitigate also with our training activities. And can I have the next slide, please? To meet this situation, we are currently providing a prototype to test the feasibility of data cubes. So we have joined up with 3 SAFs, namely the Land SAF and the CM-SAF, who are here represented by Isabel Trigo and Jörg Trentmann. And in addition, we have teamed up with the SAF for hydrology, and we have collaborated with the Global Precipitation Climatology Center and with the ECMWF to come up with a prototype data cube for drought and vegetation monitoring. And in this cube, we have for this cube, we have selected a few variables and provide them on the same grid in the same data format and using the same metadata, or using the metadata in the same form. Can I have the next slide, please? What is available on this cube, or in this cube, this is, you can see here on the list, and also from the logos who provides this data originally, and which time period the individual data records are covering, the spatial resolution and the temporal resolution that is available. Unfortunately, this cube is at the moment not available for Africa for technical reasons, and also because this is a prototype, we have decided to provide it for a cutout of Europe, but it is available on the regular latitude-longitude grid and in a CF-compliant NetCDF format. The data and the cube itself is provided on a threads server. And the total data size we are talking about here is approximately 3 terabyte. You can use the thread server and the functionalities of the thread server to subset and subsample this data, which is, I think, the big advantage of the cube, next to the fact that everything is in the same grid and data format. So you can analyze and work with this data with all tools that are capable of handling CF compliant NetCDF data. So for example, R, Python, MATLAB, or any other tools you can think of. At the moment, we have an exploration phase running. So we are collaborating with users who are interested in testing this cube, in trying it out, playing with it, to give us feedback on how it works for them, and for us to learn, for EUMETSAT and also for the SAFs to learn if this way of delivering data is appreciated by users. The next slide, please. The link that is provided here will guide you to a web page where you can find more information about the cube and details about the data record that are covered. And yeah, I also invite you, even though Africa is not covered at the moment, to let us know if you would like to participate in the exploration phase, to check out the cube. This also gives you the chance to collaborate with others, with users, with colleagues of yours, and to collaborate with us, because we are available for questions and support for you throughout the exploration phase. You can share, we would like to invite you also to share your experiences with the cube, and also to let us know what you can think of. Maybe you have ideas for some projects or questions where this cube could be useful for you. And if you could let us know about that, that would also be very much appreciated. We have throughout this period several live touch points online, of course, but most of the time we work asynchronously, so everybody independent, but there are ways to collaborate with each other. The exploration phase will be finalized in October, November timeframe. In November, there is a meeting called the SALGI meeting. This is an expert team of people working on drought and vegetation issues. Originally, they were focused around Eastern Europe. The group is growing at the moment. And the idea is that we have, during this SALGI meeting, a session also on the data cube and on applications that were that are integrated, that were developed from the cube. And this will probably be 3 days in November. The date is currently being fixed. So if you have an interest in testing this cube, you're very welcome. Then the access to the page is here. I don't know, maybe we can share it in the forum or with people who are listening on YouTube. They will, I think, receive the slides as well, so we could share them. Or you can simply send an email to training@eumetsat.int, and I will get back to you to help you get onboarded.
Good. Thank you, Christine.
Thanks very much.
Okay, good. Yeah, with the modernization process for access to data ongoing, so this is an effort at EUMETSAT to make sure that access to data is facilitated for our different users. So I hand over to Mimi for quiz number 2 and 3. You have the floor, Mimi.
Thank you. So hi, I'm back again. So please, I've added the link into the chat. So if you could please come back to Slido. I've restarted the first question. So I'm going to do question 1 and 2 because there were some problems with the first one, and we're going to give you a little bit more time. So, okay, we're going to share the screen. So I'm starting the quiz now. So question 1 is, in what year was the first successful meteorological satellite launched? Was it 1958, 1960, 1969, or 1977? You have 5 seconds more. So here are the results. Most people had it correctly. Yes, it was in 1960. And that leads us to the next question. So right now, the first place is Deborah, Matteo is second, and Jurek is third. That's really good. Let's see how it changes after question 2. The next question is, how long was the world's first successful meteorological satellite, that is TIROS-1, operational? So option 1 is 12 days, option 2, 78 days, option 3, 129 days, or option 4, 312 days. You have 5 seconds. So that is really good. So there are 2 questions which will have the same amount of answers, and the right answer is 78 days. So that's really good. Here's the leaderboard. Deborah is still, we have a new leader. That's MDB, and then Sarah, and then Bakary. So I give the floor back to Andre for the Q&A before we continue with our next presentation from the JRC. Andre?
Okay, good. Thank you so much for this exercise with the questions. So we open a short Q&A session before we embark on the next presentation by JRC. So any questions?
Yes, Andre, I'm sharing the screen. There is several questions from the Slido.
Okay.
Maybe I can read it.
Yeah.
La première question est de Nicole. Est la suivante. Bonjour, la couverture comprend-elle aussi l'île de Madagascar de manière optimale? Merci. I can answer this question. So yes, our satellites covers very well the island of Madagascar, and I think all the Landsat and the ClimateSat product that were provided, including in the previous presentation, also covers the islands of Madagascar very well. There is then another. I would like also to take the opportunity to say to the people that they can also vote for the questions, and all questions will be answered also on the live, either live or offline on the Slido. So the next question is, bonjour à tous, combien de pays africains ont-ils accès à tous ces services? A question from Caroline. And I can also answer that one. So all African countries and all users actually around the world have access to these services. I think in the first presentation you had the link to, Marie provided some link to how to get access to the service. And this will, so everybody, all the data that were shown here are free of charge and everybody can join them. The next question was also from Caroline, where there was also indeed related to the quiz. There was indeed the American launch of Vanguard 2 satellites in 1959. Also, this was an experimental satellite which lasted a few days, and Tyros, which was launched 1 year later in 1960, was considered as the first successful operational satellites in the meteorological satellite in the history. We have then a question from Olivier Tamba, which comment télécharger toutes ces présentations, how to download all the presentations. So you will see that we will have, if you go to the registration page, you will have the agenda and you will be able to click on all presentations and download them. So I will encourage you then to go. We will send you to all participants the link where to download the presentation, but as soon as this session is finished, we will upload all the presentations and you will be able to go to this registration page and download them. So the presentation will be done for the next questions. For Caroline, are the presentation, will we receive all the presentation in French? No, the presentation will not be translated, so they are in the language they were made. So if they are in English, they will be in English. If they are in French, they will be in French. We have a question from Madagascar. Is the account login the same valid for all EUMETSAT service? So here again, for the EUMETSAT services, we have indeed, you have with the new user interface, you have a single login account, and this allows you to get access to all the various services, either to your EUMETCAST accounts or also to the various other ones. And then we have two questions from Caroline. One is about comment faire bénéficier de cette expertise en présentiel aux jeunes Camerounais et Africains en général. These are very good questions. On EUMETSAT side, we really try to make a maximum of awareness about this webinar. We will also have our forum later in September, October. The YouTube video will stay also, will be available after the webinar. So we also would like to take benefit of this webinar to ask all who attend. You can easily share the outcome of the webinar. By example, the link to the YouTube video, you can share it to all your network or people that you know that would be interested to do that, and they can watch again this webinar offline and get access to all presentations. Last question, and then I give back the floor to André. L'Afrique a-t-elle une agence spatiale? Oui, je crois qu'il y a des collègues de l'Union africaine qui sont là, mais je vais répondre rapidement. L'Union africaine a créé son agence spatiale qui sera localisée en Égypte. À ma connaissance, l'agence spatiale a été créée, le lieu d'accueil qui est l'Égypte, le pays d'accueil qui est l'Égypte a été désigné, mais l'agence n'est pas encore opérationnelle. Nous pourrons peut-être demander à l'Union africaine qui interviendra demain dans la deuxième partie de ce webinaire, la session du 8 juin, de donner un peu plus de détails sur la création et la mise en opération de l'agence spatiale. Voilà. Thank you, and I give you back the floor, André, for the next phase.
Okay. Thank you so much for the question and answer session. Now we'll move towards a set of 3 other presentations. The first on the climate station. As you can see, we have a lot of satellite data available out there, and there are constraints in Africa in terms of bandwidth for online easy access to data. So a collaboration with EUMETSAT is ongoing to develop a climate station that will be connected to the EUMETCAST reception system to facilitate the generation of climate services. So I hand over to Marco Clery from GRC or Christophe Lavas from GRC on the introduction to the climate station and how they support the climate service program that Africa is implementing under the GFCS. Marco or Christophe, you have the floor.
Oui, bonjour, c'est Christophe Lavaïs bonjour. C'est moi qui vais faire la présentation aujourd'hui. Merci de donner l'opportunité à l'ensemble de l'équipe avec laquelle je travaille, donc Marco, Clerici et d'autres collègues du JRC de la Commission européenne. Et nous travaillons donc à ISPRA dans le cadre du développement d'une station climatique pour le programme CLIMSA. Alors, je vais donner rapidement un peu le contexte et un peu le contenu de cette présentation. D'abord, on fera un rapide point sur la station climatique et comment elle va s'impliquer dans ce programme CLIMSA. Je parlerai de l'implémentation technologique de cette station avec des informations sur les bases de données et les outils qui seront inclus dans cette base de données. Et enfin, je donnerai quelques exemples, notamment des toolkits qui existent et qui sont intégrés donc, à cette station. Alors, pour donner un aperçu global sur le challenge des services climatiques à l'échelle globale, il faut savoir que déjà, beaucoup de pays n'ont pas nécessairement les capacités à gérer les crises et les risques liés à ces changements climatiques. Et une manière d'améliorer cette problématique, ce manque, il y a l'accès, il y a l'amélioration et promouvoir et proposer des services climatiques, des CSIS, pour les aider à faire face à ces risques. Seulement, ces CSIS, ces services climatiques, sont des fois, pour certains pays, nécessitent d'être mis en place parce qu'ils sont inexistants, ou des fois, il faut les améliorer parce qu'ils ne sont pas nécessairement en accord avec les besoins du pays sur lequel ils sont basés. Il faut travailler aussi, c'est un autre challenge important, sur la disponibilité et la qualité des données climatiques, car elles sont souvent inadéquates pour le pays ou pour les problématiques, les enjeux qui sont présents dans un pays. Et il faut évidemment travailler sur la qualité du service climatique lui-même, c'est-à-dire de l'aspect technologique en lui-même, c'est-à-dire qu'il propose des outils et des fonctionnalités qui répondent aux exigences et aux besoins des usagers. Et pour ce faire, pour répondre un peu à ces challenges, un des principaux objectifs, je pense, une des principales manières de réussir ces challenges, c'est une meilleure interaction entre les usagers et les fournisseurs de données. Et c'est le but de ces services climatiques qui proposent non seulement un support technologique, mais aussi derrière un support scientifique et technique avec une interaction très forte entre les personnes. Alors, quel est le rôle du GRC dans ce programme et plus particulièrement sur le développement de ce service climatique lié à CLIMSA? C'est de proposer un support technologique et technique et scientifique à ses partenaires pour vraiment que la plateforme soit en lien avec les besoins nécessaires. Il est là aussi pour proposer et de capitaliser sur des produits existants, notamment des produits européens, que ce soit sur des aspects de données. Vous connaissez certainement le programme Copernicus, avec un catalogue incroyable de données qui sont maintenant disponibles. On a les données climatiques du Climate Data Store, qui sont surtout des données modèles, mais on a aussi toute l'ensemble des satellites Sentinelle, qui sont maintenant en grande partie déjà en activité. On a eu une liste assez intéressante et importante des produits proposés par EUMETSAT qui sont fortement en lien avec ces produits climatiques au cours des présentations précédentes. Et on essaye aussi de capitaliser sur des programmes qui existaient déjà au GRC sur le développement de services climatiques. On a nommé ici Puma, MESA ou GMS en Africa, qui proposent déjà des produits pour les usagers dans des contextes un petit peu différents. mais d'où le support technologique existe. Et donc, on profite aussi de ce savoir-faire au JRC pour développer des systèmes un petit peu plus développés et un peu plus en lien avec les questions actuelles. Alors, pour donner aussi une image un petit peu plus globale du programme CLIMSA, on a repris ce graphique ici qui illustre un peu tous les partenaires et tous les acteurs du projet. On a donc les fournisseurs d'accès, que ce soit le Centre européen ICMWF pour les données, on a EUMETSAT évidemment, et on a des catalogues aussi développés en interne au JRC qui vont, eux, proposer des données. Et puis, on a ce qu'on appelle les centres régionaux climatiques, qui sont indiqués en bleu en dessous, les RCC, qui, eux, dépendent de sous-régions ou régions, donc en Afrique, dans les Caraïbes ou au Pacifique, et qui, eux, discutent à l'échelle nationale ou régionale. Et donc, on voit bien que la Climate Station, qui est ici indiquée en jaune, joue un rôle pivot entre les fournisseurs d'accès et ces centres régionaux, à savoir, il s'agira donc de proposer des produits tailorés, c'est-à-dire des produits adaptés aux besoins des RCC, mais comme c'est un dialogue en deux temps, et c'est un dialogue dans les deux sens, la Climate Station et les activités du GRC sont aussi là pour essayer de faire remonter aussi des demandes des usagers, donc de ces RCC. Et donc, il y a un rôle pivot de cette Climate Station qui est là pour proposer des produits le plus adaptés possible aux centres régionaux. Je pense qu'une présentation sera spécifiquement dédiée à CLIMSA juste après, ou dans 2 présentations, et je pense que la présentation sera plus en détail sur ce programme. Donc, les points principaux de la station climatique qui sont nécessaires à mettre en place, c'est qu'on a plusieurs, dans le cahier des charges, on a plusieurs objectifs. Tout d'abord, il s'agit de faire un système opérationnel qui donc fonctionne 7 jours sur 7, 24 heures sur 24. On va inclure dans cette Climate Station des fonctionnalités demandées et des applications demandées, donc c'est-à-dire automatiser des chaînes de production avec des méthodologies préétablies ou des calculs préétablis, et qui permettent évidemment d'avoir une très bonne fiabilité des produits dérivés et une traçabilité. Et bien évidemment, l'objectif principal, c'est de faciliter la dissémination et la reproduction des produits distribués. Et c'est un des rôles clés de cette Climate Station. Les 2 objectifs donc, de cette Climate Station, c'est avoir en un seul point d'entrée, en un seul point d'accès, pour l'usager, différentes sources de données qui peuvent être d'origine totalement différente. On parle de données satellites, notamment donc, les produits CMSAF, HSAF, qui ont été présentés précédemment, mais aussi des données modèles. On a parlé du Climate Data Store de Copernicus, qui produit des données modèles notamment, ou bien des données observation sol, qui peuvent répondre à d'autres objectifs pour l'usager. Donc, en un seul point, grâce à cette Climate Station, on va avoir accès à cet ensemble cette constellation de données d'origine différente. On va aussi avoir des sources d'accès à ces données qui sont des sources différentes, que ce soit EUMETCAST via une antenne de EUMETSAT, mais aussi on a des données qui peuvent venir d'Internet, ou bien d'autres types de cloud computing, comme notamment ce qui est fait au JRC, des produits qui sont développés au JRC et qui seront inclus aussi dans le catalogue. Et donc l'objectif principal, c'est donc de réduire cette charge de données à l'usager et de transformer l'information, enfin de transformer la data en information pour que l'usager ait bien plus de temps et de facilité à acquérir ces données et avoir à disposition des données bien plus facilement interprétables, et donc passer plus de temps à l'analyse et à l'interprétation qu'à essayer de gérer des données de sources différentes, d'origines différentes. Alors, comment s'organise cette Climate Station? Donc ici, je vous propose un schéma d'organisation de la station physique avec 3 étapes majeures. Donc, une première qui est la réception et l'acquisition des données. Elles sont de 2 types. Soit le système est équipé, le centre est équipé d'une antenne EUMETCAST, il va pouvoir collecter certaines données via cette antenne, donc sans besoin d'Internet. Ou bien on a d'autres types de données qui sont, elles, téléchargeables via Internet et qui seront donc téléchargées sur 2 ordinateurs qui constituent la Climate Station physique, sur le centre, dans un centre régional. Et là commence le deuxième étape qui est là, le traitement des données, indiqué ici en vert, et avec des chaînes donc, dont je parlais tout à l'heure, des chaînes automatisées, des chaînes de processing automatisées pour soit définir des produits dérivés, des indices qu'on dit tailorés, des indices qui sont donc applicables et qui ont du sens pour des non-spécialistes, des usagers non spécialistes, mais qui ont besoin d'une information très vite compréhensible, avec donc, sans rentrer dans les détails, avec des toolbox qui peuvent être intégrés, notamment les toolbox de CDO. On a R aussi qui est intégré dedans. On a de Jupyter Notebook qui permettra aussi de faire certaines manipulations. Et au final, qu'est-ce qu'on a en sortie de cette station climatique? On peut choisir deux types de sorties. D'une part, on peut récupérer ces données pour les utiliser dans d'autres logiciels. Ça peut être Digis ou ça peut être n'importe quel autre logiciel, dans des formats qui sont transposables, évidemment. Ou bien la station climatique possède sa propre méthode, sa propre fonctionnalité d'analyse de données qui permet de tracer des cartes. Ici, c'est un exemple que je donne. Donc, on a un espace de travail où dedans, on va pouvoir générer des cartes avec tous les types de données. On peut zoomer, dézoomer, faire des graphiques, des séries temporelles, faire des scatter plots, une grande quantité de fonctionnalités qui existent déjà, sur lesquelles on s'appuie par l'expertise qu'on a avec les projets antérieurs dont je parlais tout à l'heure, comme GMS en Africa. Et donc, on va pouvoir utiliser très simplement des données complexes issues de satellites ou de modèles et les afficher tous ensemble sur un espace de travail identique. En parallèle de ces travaux, et pour bien construire correctement ce service climatique, on a donc un dialogue qui est établi avec les RCC, avec les services climatiques. On a lancé notamment des enquêtes qui nous a permis de mieux connaître les besoins et disons déjà mieux connaître les usagers potentiels de ce service climatique, notamment leur connaissance des produits et des sources de données, donc les produits satellites ou les modèles, mieux connaître leurs incertitudes aussi, et pour identifier quels sont notamment, où est-ce qu'on pourra mettre un effort particulier lorsqu'on va mettre en place les trainings, des supports techniques et aussi la simplification de produits dans les chaînes de processing. On a aussi, grâce à cette enquête, grâce à cette enquête, on a pu aussi identifier les données qui sont importantes à implémenter dans ce service climatique, que ce soit les données modèles. Ici, on indique notamment RA5. On a parlé ce matin, vous avez entendu les présentations des différents produits, notamment de EUMETSAT, qui sont très intéressants pour le service climatique et qui seront intégrés aussi dans les données. Et puis, on a évidemment les produits dérivés qui, eux, sont plus tailorés, notamment le monitoring des vagues de chaleur ou des prévisions de vagues de chaleur, qui sont des produits qui seront automatiquement dérivés du service climatique. En fonctionnalité et en outils, on a des produits existants qui sont implémentés dans cette Climate Station ou qui sont simplifiés avec cette Climate Station. Par exemple, un dialogue possible avec le ClimSoft, le software ClimSoft de WMO, où on a un dialogue qui est possible entre la Climate Station installée et une base de données ClimSoft qui pourrait être aussi présente dans le centre climatique. On a, en autre exemple, ce toolbox Impact qui a été généré, qui a été créé pour le milieu forestier, qui traite, qui télécharge, qui traite les données météosat ou des données satellites diverses pour générer des cartes très précises pour le milieu forestier, notamment sur l'évolution des forêts, les problèmes de déforestation ou de feu. Et ce software Impact a été complètement intégré au service climatique, au service climatique ClimSat, pardon. Et la toolbox va automatiquement télécharger les données dont elle a besoin pour générer les produits que l'usager a demandé. Donc, elle est déjà implémentée dans la Climate Station et elle peut être utilisée d'ores et déjà. Et donc, on donne ici un exemple d'un composite sans nuage pour une région donnée qui permet de caractériser un peu le milieu forestier d'une région. Et le dernier outil qui va être installé, qui est en cours d'installation, c'est le Fitness for Purpose. C'est aussi quelque chose qui a été développé au sein du centre de recherche commun de ISPRA et qui vise à mieux étudier les incertitudes qu'on pourrait avoir pour une variable donnée lorsqu'elle est issue de différents produits. Et donc, là aussi, on a cette fonctionnalité qui existe déjà au GRC qui va être implémentée, où on va sélectionner une variable, différentes sources qui produisent cette variable-là, des années, par exemple, une année particulière, et on va pouvoir comparer ici, par exemple, c'est l'albédo de différents produits, et on va pouvoir mesurer l'incertitude qu'on peut avoir sur ces produits complexes et identifier peut-être des forces et faiblesses d'un produit par rapport à un autre. Cette fonctionnalité sera bientôt intégrée au service climatique. Alors, pour très rapidement conclure sur ma dernière slide, donc, il y a en cours ce dialogue, cette co-construction d'un service climatique qui va être totalement gratuit en termes de software avec les RCC et les usagers futurs, où on a identifié les variables, les produits et les fonctionnalités dont les usagers ont besoin. On a développé l'aspect technologique de ce service climatique qui intègre donc certains toolkits dont on a parlé précédemment. Un prototype est en cours d'être distribué à certains RCC pour le moment, donc notamment ICPAC et ACMAD, en incluant certaines premières fonctionnalités, je dirais. Et bien entendu, ce service climatique sera distribué donc l'année prochaine à l'échelle nationale pour tous les services météorologiques, notamment en Afrique. Et en espérant que les conditions sanitaires s'améliorent, on pourra remettre en place des systèmes de training et de workshop pour l'utilisation et le bon usage de ce service climatique auprès des usagers. Je vous remercie.
Merci Christophe. Nous allons passer directement à la présentation de Christine avant la dernière. Christine, si possible, aller assez vite. Donc, elle va nous parler de la coopération au niveau de la formation mise en place à EUMETSAT pour l'Afrique, les réalisations passées et puis les perspectives en termes de formation autour des services climatiques. Christine, you have the floor.
Thank you very much, Andre. So this is an overview on the EUMETSAT climate training activities for Africa. Can I have the next slide, please? So what is the goal of these climate training activities, and who is our target audience? So our prime target audience are the scientists and the technological staff in the regional climate services and in the national meteorological services. But I would not exclude downstream services because yeah, they can benefit from our trainings as well, such as also students in universities, especially if they're in their late stages of their studies towards completing a study, or even if they're in their PhD thesis. So the aim of the training activities is to enable participants to find where to know where, or to find satellite-based data records, so they know after the training where to go to find what they need, and then also to enable them to identify which of the satellite data records are best suited for the project or for the current questions they have, because you have heard there is quite a lot of stuff, quite a lot of data out there. And another challenge besides accessing the data is to really be able to judge and identify which are the best data for the question or for my project that I have. So this means also to consider which temporal coverage do I need, which spatial coverage is sufficient for me, what are my accuracy requirements versus how accurate are the data, how high is the uncertainty in the data themselves, where can I find this out, and to know where to find further information that is needed while working with the data scientifically. Then, of course, accessing, downloading the data records of interest, where to do that, how to best do that, and to be able to finally work with the data with a suitable software. We do not force anybody to use a particular software. However, in our courses, we work a lot with R-based tools, but if people are experienced in using Python, CDO, or AnyGIS any GIS tools, we try to support them as well with the questions that are specific to the data records themselves. And we enable people to combine the satellite-based data records also with data from other sources, because we are well aware that satellite data are only one source of information people may use in their applications, and certainly not the only one. So this is also a topic in the courses, and also especially the validation of the data records. So the data records that are provided from EUMETSAT are usually very well validated. Nevertheless, the first step is usually, and that's absolutely normal and yeah, very well justified as well, that people compare with what they know. So, for example, with the station measurements next door, just to get a feeling for the data, and that's where we support them. We provide support as well. But then also to help them to interpret the results of their analysis. What does that mean, and what specific characteristics do you have to consider when working with the different data records? So we also usually bring specialists on the data records we teach on to the courses. Next slide, please. Yeah, as I said, we bring experts to the courses. That means we always do training in collaborations. This is, of course, our first natural partners are the SAFs with which we are collaborating a lot when it comes to climate training, but also, of course, with the Copernicus services, and I think most important with WMO and the regional training centers, also across Africa. Next slide, please. Yeah, what do we work on? So as I said, we would like to enable participants on where to find the data, how to access them, how to handle them, to visualize, to combine with other data sources, how to interpret them, etc. We work exclusively in the climate trainings on retrieved geophysical variables. So the subject of our trainings is not the interpretation of RGBs, for example. This is what my colleagues are doing here. But in climate trainings, we work with the satellite-based but already retrieved geophysical variables. The next slide, please. We have several training opportunities available to you. So of course, these days we have to work a lot online, but also pre-COVID, we already had quite some online learning opportunities available. And one of them is learning modules that are created for self-study. There is a module available on the usage on how to do climate analysis using the CMSAF-R toolbox, which was mentioned this morning by Jörg Trentmann. And we are currently working on a learning module on satellite-based climate data records to understand better what climate data records actually are and why they are produced. This is close to being finalized, and we expect that this would be published in the next couple of months. And you will find the link on the EUMETSAT training pages for sure. And our big, or say intense training courses are usually blended training courses. So blended means a combination of online and face-to-face trainings. The duration of those is several days to several weeks, depending on the contents and on the audience. But we also provide short courses. So at the moment, we provide roughly every couple of weeks with a summer break where we do no short courses, but we provide every couple of weeks short courses offered by EUMETSAT around different subjects, also about climate trainings. And the next one that is coming up is on June 16th. It starts at 12 UTC, and it is about the climate data record of soil wetness, also in the root zone from the HSAF. So if you're interested, come to our training pages and you'll find more information about this and how to join. These short courses have a duration of 2 to 4 hours. And another form of short courses is those that are offered in the context of, for example, scientific meetings, to bigger conferences, etc., where we collaborate with organizers and offer a 2 hours or also anything in between 2 hours or 2 days can then be considered as a short course that is either integrated into a meeting or happening just before, just after that meeting. So we use the fact that people are already there. So if you know about scientific meetings, or if you're organizing one and you would like us to give a short course there, then we will be happy to know about that. The earlier, the better, so we can organize ourselves. And of course, we provide mentoring. This is traditionally people who have already participated in one of our trainings or who have worked with our data already. If they have specific questions or are in the middle of developing an application, then of course, we also provide individual one-on-one support. And you can contact us either via the EUMETSAT help desk or again via the training@eumetsat.int email address. The next slide, please. So an example of how our blended climate training courses worked in pre-COVID times. They were composed of an online phase and a classroom phase. The online phase usually had a duration of 2 to 3 weeks. People were not expected to work full time on that, but say as an example or as a rule of thumb, you were expected, or people were expected to work about 10 hours over the duration of 2 to 3 weeks on the content that was provided to them, just to prepare themselves for the course. And in the classroom itself, most of the time was really dedicated to hands-on work. And people were motivated to work on their own laptops with the idea so they could go home with a running working environment on their laptop, because we all know how it works. You sit in a classroom, everything is really nicely prepared, and then you go home and already at step 2, you fail. And this is what we would like to prevent while helping people installing a working environment on their laptop, or to teach on systems that we know they have available in their home services as well. Then people work on their own projects that they bring to the classroom, because I'm convinced that, or we are all convinced that if people come with real life questions, they could benefit the most. So we work with them to help them apply the data to their real needs. And in the next slides, I show you a few examples what people come up with until the end of a training course. So this is one result, somebody who have worked with evapotranspiration data from the Landsat, and here you can see maps that this participant has created for the same day of a year, working with reference transpiration, with the actual transpiration, and he has developed a drought index, or calculated a drought index from that within the week, with support from experts around him. Next slide, please. Another example is somebody who worked with the LST data from EUMETSAT in this case, although LST is also available from the Landsat. And this is again already the first question: which LST data set do you best use for your application? And that's something we're discussing then with the participants in the course, to find out together what is needed, to not only to give them advice, but to help them to be able at the end of a course to decide on their own which of the 2 data records is the best for them to use. And this participant here has compared the LST data with 2-meter air temperature measurements from a station he knows, just to find out how these 2 correlate and what's the relation between these 2. Next slide, please. Yes, and this is from the same participant who has then continued working with the land surface temperature data from the EUMETSAT for Nigeria, and the maps you can see here. So he has analyzed different seasons and how the land surface temperature looks in these different seasons, and you can clearly see the differences between the dry periods, the start of the raining season, and then well into the rainy season, how the land surface temperature has developed. And this is the benefit of having a long-term data record. So you can look at an average of several seasons together. Next slide, please. Yes, and that's another example, also working with the LST data, looking closer at one station and the situation of a station of a region throughout throughout the time series. So what's the average seasonal cycle and other statistical information you can get out of these data records. And we also help with the interpretation of those. Next slide, please. Yes, and I think this was already also mentioned, using the solar radiation data sets from the EUMETSAT in this case, to see or to find out the solar energy potential. In this case, we are looking at an example for Senegal, and maps like these help to identify the best locations for where to locate solar energy power plants, or to decide which kind of power plants will be most efficient in which regions. Next slide, please. Yeah, so as we have learned today, or as you hopefully learned today, is that satellites play an increasing role in monitoring and understanding and analyzing climate. And EUMETSAT does its best to support the users, or to support our users and you in exploiting these satellite-based climate data records and get the most out of it. So we are keen to support you, and we are also keen to learn about your needs, because you are the experts in your field of expertise, and we cannot really help you when we don't know exactly what you're doing. So this is another motivation to please get in touch with us. Let us know what you're currently working on, so that we can find out together on how we can best support you, and what formats of training would help you best. Because this in turn also helps us to develop new products, which then in turn benefits you in providing better services. So if you'd like to find out more, then you can visit our training.eumetsat.int web pages, where you can find all the training activities that are currently announced, and also find upcoming training activities, or send us an email to training@eumetsat.int if you want to get in touch directly. Thanks very much.
Thank you, Christine, for this presentation, which has highlighted the need for training on interpretation and communication. And here we have a clear role to play by regional climate centers to become data collection and production centers, generating products and their catalog for the countries. So we will be working with EUMETSAT to move forward on this aspect. Mimi, you have again 1 minute for the quiz before we have the last presentation from Secretariat, ACP Secretariat.
So thanks a lot. So we're going to continue. Now it's question 3, and it's a fairly simple one. And the question is, which satellite is this? So if it's too small for you, you can press the picture and it can be zoomed. So you still have some time to vote. So the 4 options are JSON 3, MSG 10, ENVISAT, or GeoES 15. You still have 2 seconds. That's it. So let's see the results. So yes, most people had it correctly, 71%. Yes, it's JSON 3. Very good. So let's look at the leaderboard right now. Right now, Sarah is leading with 2 points, followed by Revo and then Jörg. Very good job. Let's continue with question 4. And that is, how long did the MFG, the EUMETSAT first generation series, last altogether? Was it 10 years, 20 years, 30 years, or 40 years? So your remaining is 10 seconds. Get your votings in. Get it in. 3 minutes, 3 seconds more. 2, 1. So the results. Most people voted for 46. Most people voted for 20 years. Let's see the correct answer. In this case, no, it was 40 years altogether. So it lasted until 1997. So here you go. And here's the leaderboard. Sarah is still leading, followed by Jörg. This time Riva went down to 3rd place, but you still have a chance to win the whole thing. So that is it for now. The last question is going to follow after the last presentation. You're going to see all the results. Here you go.
Okay.
André?
Good. Okay. So always OSCPS with the presentation on the capacity building under the Climate Services for Africa program. Dr. Fata is here now.
Yes.
Okay, you have the floor, sir.
Yeah, thank you for giving us the floor. We thank EUMETSAT for giving us this opportunity to present to the audience what is the capacity building we are preparing for assisting the RCC in their program. Of course, we are here under intra-ACP Climate Services and the related application, which is a program funded by EU. And this program is an initiative of OSCPS Secretariat, which is the Organization of African, Caribbean, Pacific States. We are going just to take you through, yes, the next. Yes, just to show you at least what is our vision on the capacity building under CLIMSA. Yeah, so the first part will be to give you the objective of the capacity building in terms of the contribution of the satellite in climate monitoring and assessment. We are going to present the assessment need on climate services, what we did with our expert. And also through this assessment, we will present the capacity building layout, training catalog as small conclusion. Yes, next. Yeah, so as I said that this presentation is really covering only to show you the objective of the capacity building in climate monitoring and assessment, and to give you the overview of the capacity strategy layout component. Yes, next. In terms of the capacity building for climate monitoring and assessment for RCCs, we are presenting this map at least to show that in OSCPS, we've got more than 48 countries from Africa. There is a 17th and the 16th country in Caribbean and the Pacific, where we have one regional climate center in Caribbean, which is already designated by WMO as the WMO RCC. We have one regional climate center in Pacific, which is under demonstration phase. And in Africa, we have two regional climate centers who are already certified, ACMAD and ICPAT. And we are having agreement CSC, Central Africa Climate Application, and the Indian Ocean Network, who are still under the proposed stage. And they need, through the CLIMSA program, to go through all the requirements in order to be designated as a WMO RCC. So in terms of capacity building on monitoring climate and assessment, we are saying we need to promote fit for purpose of climate monitoring application, including climate analysis, watch from data, from reanalyze data, and from satellites. What is the expected output of this component in the capacity building to capacitate to generate climate analysis, integrating all the existing practices on climate indices? We are also trying to capacitate the regional climate center to generate the status of the climate and the climate services. Now you are going to see that things are going to be two: the status of the climate as the climate science, and the status of the climate services development over all the RCCs. We are also intending to develop capacity of managing the climate data requirement for climate monitoring. And last not the least, to capacitate also our RCC in using the big data products from satellite, reanalyze and for monitoring and assessment. So for the big data, we are intending, I will really give more detail when I'm going down in my presentation. Yes, next. Why really capacity building is very important? We are entering a critical period where other regions are making available all the data, even for the private company. I heard already my colleague told me that in Mali, they're having a problem because the private company who have access to Copernicus data have developed some tools and products giving the forecast in Mali, which sometimes challenge the product from the National Meteorological Department. If our people are not well trained, they are going to lose their relevancy in terms of providing climate information, especially from Copernicus open data, where everything is there. Any private company can come and produce something. So we need already to make our regional climate center more competitive with any other provider can come in the region. Next. Yeah, let me just give you now the assessment we did on the climate services status. According to WMO climate services checklist, our expert has gone through the survey, and we found out that among the climate services functional category, where we have the basic services, we have the user interface platform, we have the climate services application, we have the capacity building, and we have also the socio-economic benefit of climate services. On those functional climate services, in terms of the category, we have the basics, the essential, the full, and the advanced. You can see how all the results are declining toward the full and advanced. What does it mean? That African country or RCC are more able to provide only the basic services. But among the basic services, there is a low percentage on the capacity building, which is it meaning standing for technical advisory services and training to address capacity development need for climate services provision and use. So you can see that in terms of technical advisory capacity, even for the basic climate services, we have a low percentage. That meaning that capacity development is one of the key needs in Africa. And as we are moving for the advanced products, you can see even the advanced, they are only 10% covering the advanced products. This is really showing the necessity for us to build capacity in our RCC. Next. So, in terms of that assessment, what did we find in terms of the regional status? In the range of the capacity functional categories, we have here in monitoring all the region have got the deficits in terms of capacity for the full and advanced level in terms of the requirement. That meaning that we need really to focus our capacity building strategy, focusing how to reach the full and advanced criteria of the monitoring products. And you can see for the others climate services functional level, there are some regions are doing well, but others are still needing something to be done. Next. In terms of the capacity building need, we found out that, yes, thank you. In terms of meteorological infrastructure and the IT assessment, there are more need in terms of internet connection, automatic message restricting system, network observation, the high performance computers. You can see what is really the need in terms of the meteorological infrastructure. In the second category of weather forecasting and the climate assessment, numerical weather predictions, climate modeling, climate monitoring, and socioeconomic impact assessment, as I said. You can see also in institutional organizations leadership, we need to train our regional centers on capacity management system, because today, WMO have introduced another requirement to provide climate services meeting to user requirement is the QMS, quality management system. So all our climate services must comply with the quality management system of the climate services. So that's one also the area we need also to capacitate, and also not the least in communication and service delivery. That is also one of the needs we found out in our survey. Wait, next. So our capacity building is based on the output of distinguishing the competence for the beginner, practitioner, expert, and the trainer. It will be based on the capacity on climate services category, dealing with the thematic sectors, as you know, and we are going to have the level of training. Next. This is the pillar of the capacity building. The first one will be stakeholder need assessment. Before to do anything, you need to assess and to have the capacity how to undertake need assessment. The second pillar is climate services information and application improvement. We need to see how to improve what exists already today. The third pillar is the management, the leadership, and policy development. People to know how to manage quality management, the leadership of transforming the services, and also the policy development, because one of the output of our services is to mainstream climate information to strategy, projects, and policy. The next pillar is climate intelligence. So, no, come back first. Sorry. Yeah, please. I said the next pillar was just the climate intelligence, innovation, and knowledge development. We need to know how to use the artificial intelligence now to improve our seasonal forecasts. And we need also to train about communication and services delivery. And the last will be in terms of the infrastructure, technology, and tool development. Those are the key pillar we are going to have in our capacity to train our RCC to develop the climate services. Yes, next now. So in terms of the training catalog, we are going to have the climate services functional process. We are going to have the climate services functional category, skill need, how to fill the gap, training scaling, monitoring, and evaluation. So this slide will just cover for the last two, the training scaling and the monitoring and evaluation. Next. Yeah, so in terms of the training scaling plan, we are going to have the program to be discharged, to be trained in terms of the global level. Like what we are going to say, the climate risk informed decision making analysis, CRIDI, socioeconomic benefit tool, leadership, and so on. We are going to have also the training at the national level, training at the regional level, and the training at the community level. Next. In terms of the monitoring and evaluation of the training outcome, this is how we are going to evaluate the successful training outcome in terms of the learner feedback, learning output in terms of a change on job performance, learning impact on job performance in terms of the objective of the organization, learning output in terms of the organization objective. For example, how those training gonna improve RCC to be accredited as a WMO. That could be one of also the assessment of the training we did, if it will help the RCC to be accredited. So in finish, the organization objective of producing, making available, making data accessible, making product reliable, accurate, that should be the target of our capacity building. That way, we like really to bring all the RCC under these climate services capacity building training over OECPS. Next. Thank you for your attention. This program, a strategy, will be available, and we think that for the next 6 months, we are going to start our program, but it should be first validated at the steering committee. After the steering committee have given the go-ahead, the green light, we'll start now our implementation. Dr. Andre, thank you for the floor. You are mute, Dr. Andre, you are mute.
Good. Thank you. Thank you, Dr. Faka, for this insightful presentation, highlighting the role of capacity building to actually support the certification process of African regional climate centers, and also their effort to introduce quality management in climate services. So we'll move forward very quickly with the question and answer. Vincent, have you collected some questions that we can respond to? Or
Yes, I'm sharing now the questions here on the slide. So there is a first question from Mike Sankambi to Christophe. En français, la question, quelle est la différence entre la e-station et la climate station?
Alors, merci pour la question. La Climate Station, c'est une évolution de la e-Station qui va inclure des technologies plus avancées. On a parlé de Jupyter Notebook, d'un système de Docker ou de Python 3, par exemple. On a aussi plus de produits, puisque la Climate Station va se focaliser sur l'évolution climatique et les prévisions. On a l'intégration de beaucoup de produits issus de Copernicus Climate Data Store ou de IRI. Donc, elle est plus orientée climat. On a des produits qui peuvent exister dans les deux systèmes, mais on a clairement une évolution vers la Climate Station.
Merci.
Vincent?
Oui, merci. We have a next question from Lucas Okar. How would we be able to explore wind data for renewable energy use? So maybe the question is either to Christine or Marie or Isabelle or Jörg, I don't know, from the SAF or from EUMETSAT, if one of my colleagues would like to take the floor here.
Marie, would you like to take that question?
I'm not really sure about the answer here, because I think it's much more about probably surface wind you are talking about, but I'm not sure.
DWD also may answer.
This is Jörg Trentman. I can try to answer.
Yeah.
So very often, typically, satellite data is not used to use wind information for renewable energy, because the wind typically is required in about 100 meters above the surface. This is very difficult to estimate, to derive from a satellite. So very often, weather model data, very often reanalysis data is harvested here for the information that is required to assess wind energy potential. For example, the ERA 5 from ECMWF or from Copernicus.
Just to complement, I fully agree with you, and this kind of product could be integrated into the climate station. It's part of the variables related to the energy thematics that could be integrated, and that expected to be integrated into the climate station, coming from the models reanalysis.
Okay, we have three other questions. So one from une question de Madagascar. Bonjour, est-ce qu'on peut avoir les diapos après, s'il vous plaît? Oui, les diapos seront disponibles sous le lien, sous la page d'enregistrement. On vous enverra à nouveau le lien une fois que nous aurons mis toutes les présentations en ligne pour cette première session. We have then a question from Gopal Kishan Bigu. Hi, the MESA station at Mauritius has never worked as expected. The workstation for MESA was supposed to have a dual boot as per the explanation given by ones doing the installation Telespatio. Can I have an update, please? So this is a question related to the functioning of the MESA station that was deployed as part of the MESA project in 2016-17. So for that, I will encourage you to raise your questions to the help desk, EUMETSAT at EUMETSAT ops, sorry, the email is ops@eumetsat.int, and our engineer will get in touch with you to see how to restore your MESA station. We have two questions from Caroline pour le Dr. Faka. How can African countries assess climate service needs when we don't have a good infrastructure research center? And then I think the second question is very linked to that one, still for Dr. Faka. Do you think we should first create space research infrastructure in Africa before thinking about training? Alors, Dieudonné Faka, si vous voulez bien répondre à cette question ou suggestion.
OK. En fait, la question est bien posée. Je crois qu'ici, il est question simplement de manque d'information. L'Afrique est bel et bien dotée de l'infrastructure de recherche pour faire le suivi, analyse, processing de données en vue de générer des services climatiques fiables à donner aux utilisateurs. Si nous voyons ce que ICPAT, East Africa fait, ils ont presque toute l'infrastructure. Si nous voyons ce que ACMAD a, le centre a aussi l'infrastructure. C'est quoi qui manque? C'est peut-être l'information de savoir quel type de produit faut-il recevoir de quel centre. Donc, je crois qu'ici, c'est question simplement en termes de l'information que nous aurons l'opportunité aussi de voir comment mettre l'information à la disponibilité, à la disposition, disons, des usagers. Je vais dire, par exemple, le centre d'où je venais, Centre climatique de l'Afrique australe, SADC, CSI, ils ont toute l'infrastructure qui a été payée par BAD, Banque africaine de développement. Mais peut-être que les gens ne savent pas qu'ils ont des produits suivis, des produits réguliers. Simplement, peut-être parce que le centre n'a pas cette politique de bien faire connaître leurs produits. En termes d'infrastructure, EUMETSAT venait même d'installer des antennes de réception encore de produits pour la création des services, des alertes rapides pour la gestion des risques et des catastrophes. Et ces instruments sont toujours en cours d'installation pour certains centres. Donc, nous ne manquons pas des équipements, nous ne manquons pas des infrastructures de recherche, mais c'est simplement de savoir quel type d'information, quelle est la communication entre les centres et les usagers. C'est là où des fois ça fait défaut, mais néanmoins, l'Afrique a déjà le minimum pour répondre aux besoins de ses usagers. Pour plus d'informations, nous pouvons avoir contact avec eux pour leur donner beaucoup plus de contacts d'où ils peuvent tirer l'information qu'ils ont besoin. Merci.
D'accord.
Il n'y a,
oui.
il n'y a pas d'autres questions.
Merci. Oui, juste pour maintenant compléter ce que Dr. Faka vient de dire, en réalité, dans la stratégie spatiale de l'Afrique, il y a l'aspect infrastructure, c'est-à-dire développer des satellites pour mettre dans l'espace, mais il y a aussi l'aspect exploitation optimale des satellites existants. Et le programme dont nous parlons actuellement, c'est de renforcer les capacités pour que l'Afrique exploite de manière plus optimale les produits des satellites existants, qui déjà donnera pas mal de produits et services. Donc, actuellement, nous avons le quiz également, la question 5 sur Slido avec Mimi. Mimi, please. Question 5.
Okay, let me just see. Yeah, Dr. Faka, avez-vous pensé à évaluer ou dimensionner l'infrastructure?
OK. En fait, c'est ce que je venais de dire, que tous les centres régionaux, ceux qui sont déjà opérationnels en Afrique, je prends pour EUMETSAT, qui a déjà l'infrastructure requise pour le fonctionnement d'un RCC, en termes même de réception des images satellitaires, en termes même de HPC, donc des High Performance Computers, pour le traitement, le processing des données. Nous allons aider, par exemple, les centres africains, et comment je voulais dire, de l'Afrique centrale, qui n'est pas encore installé. Ça, c'est le seul centre que nous allons vraiment dimensionner quels seraient les types des informations, des infrastructures qu'ils ont besoin. Mais les anciens centres ont déjà des équipements minimums qui leur permettent déjà de rendre le service. Ce que je disais, c'est question simplement de l'information. Et comme je le disais tantôt, visitez par exemple le centre SADC et vous verrez, vous serez surpris de l'équipement qu'il y a sur terrain. C'est l'exploitation et la communication de l'information générée par ces centres-là qui fait défaut. Mais néanmoins, les centres existent et ils ont déjà le minimum des équipements. Et pendant ces programmes, nous aurons encore aussi à renforcer les équipements pour ceux qui doivent vraiment les upgrade pour que ça devienne à un niveau avancé. Donc, je ne vois pas tellement une question en termes des équipements qui manquent les centres régionaux. Les équipements sont là pour faire le minimum dans leur mandat. En effet, s'ils n'avaient pas des équipements, comment ils pouvaient être qualifiés pour être accrédités comme un centre de l'OMM? Parce que pour qu'un centre soit accrédité comme centre de l'OMM, il y a des critères que ces centres-là doivent répondre. Donc, ne soyons pas complexés, parce que je sais en fait ce qui nous fait défaut aussi. Les gens ont plus confiance d'aller ailleurs pour chercher des informations, alors que l'information est juste à quelques mètres de chez eux, ou juste comme on le dit en français, l'information est au bout de son nez, mais il est en train de voir plus loin. Consultez vos centres régionaux et vous vous rendrez compte qu'ils ont de quoi à vous suffire. Définissez vos besoins. C'est là où nous voulons venir avec le EUMETSAT. Quel est le nouveau exigence, les nouvelles demandes des usagers et quel type de produits et quel type d'infrastructure qui doivent aller ensemble pour produire cela. Mais en termes de besoins élémentaires, comme je l'avais défini dans ma présentation, le service climatique est catégorisé. Le besoin basique, le besoin essentiel, le full et l'advance. Et vous avez vu que déjà, besoin basique, essentiel, il y a des centres qui répondent déjà aux besoins. Notre mission, c'est maintenant avancer les services climatiques au niveau full et advanced. Bon, voilà à la question, nous disons qu'il y a déjà le minimum qui peut être utilisé. Ce qui nous reste, c'est amener à un niveau avancé les équipements qui existent. Merci.
Thanks a lot. So I would just like to refer to the last poll question. So everybody go to your polls. The last question is going to be presented. The last question is, how long is MTG foreseen to be operational? That's the newest one.
MTG stands for METOSAT third
Third
generation.
generation, of course, yeah. So you're meeting with 5 more seconds. See the answers coming in. So very interesting. So most people answered, 40% answered 40 years. The correct answer is this time, it's 20 years. So that is what it's going to be foreseen. We're going to see how long it really takes, but that is the planned amount of time. Here is the leaderboard. Our winner for today is Rivo Randia. Rivo from the NMHS Madagascar. Here you are, congratulations. Number 2 is Vansa Gavalio.
No.
And number 3 is Deborah. Also a very, very good job. And then I'm also going to give a shout out to Sarah, who is 3rd place. Thank you.
Thank you, Mimi, for the quiz. So we'll now move to the closure of the session. I would like to thank all the presenters, the interpreters, as well as participants for taking part on this session. You still need to consider using social media, EU Africa, and also at EUMETSAT. Recording can be done, or can be records of this event can be seen on YouTube page. As you have seen, we have touched the different components, the products in the different components of a climate system, from the biosphere to the atmosphere, the cryosphere, and the land surface. You are very much encouraged to actually download the presentations and read them again and ask questions if needed. And we are looking forward to seeing you tomorrow for the second session, which will really go from the products to the services, showing the benefits that the climate observation from space provide now and will provide in the future for sustainable development of Africa. Goodbye, and thank you again for all.
Bye-bye. Thank
Merci.
you.
Goodbye. See you
Goodbye,
tomorrow.
everybody. Until tomorrow.